In this video, we'll be taking a closer look at pH calculations. The pH scale is a logarithmic scale that indicates how acidic or basic a substance is. If the substance has a pH of 7, it is considered neutral. As the pH value decreases and approaches 0, the substance is considered to be increasingly acidic. As a pH larger than 7 increases toward 14, it is considered more and more basic. The formula that we use to calculate the pH is pH equals the negative log of the hydrogen ion concentration. These brackets around the hydrogen ion indicate molarity. pH can be thought of as potential for hydrogen or hydrogen power. And as we mentioned, it's a logarithmic scale. The way that we find the pH of a substance is to take the molarity of the hydrogen ion present in the solution and take the negative log of that, and that will give us our pH value. Here's a sample problem in which we calculate the pH. What is the pH of a solution that contains a hydrogen ion concentration of 3.6 times 10 to the negative second molar? The first thing we do is bring up the equation for calculating pH, which again is pH is equal to the negative log of the hydrogen ion concentration. In this question, we are given the concentration of the hydrogen ion, 3.6 times 10 to the negative second. To find the pH of this solution, we simply plug in 3.6 times 10 to the negative second for our hydrogen ion concentration, and then we take the negative log of that. And when we plug that into the calculator, we find that the pH of this solution is 1.4. If you remember from the pH scale, any number less than 7 is considered acidic. As we approach 0, or in other words, the pH value gets less and less, then the substance is getting more and more acidic. So a pH of 1.4 is considered a very acidic solution. Occasionally, you'll be given problems in which you have to calculate pH, and the only thing that's given to you in the problem is the molarity of a strong acid. But we can solve these problems in a relatively straightforward way if we remember that when we say an acid or base is strong, what we mean is the acid or base is 100% ionized in water. So if the acid is monoprotic, or in other words it contains one ionizable hydrogen ion, then the molarity of the acid is the same as the molarity of the hydrogen ion, since it will be 100% ionized in solution. Here is an example of a problem in which we are asked to calculate the pH of a 0.050 molar hydrochloric acid solution. Now, hydrochloric acid is a strong acid, so we know that the molarity that's given to us in the problem of the acid is actually the same value as the hydrogen ion concentration, and we know that this will be 100% ionized in solution. We can go straight to the pH equation where we take the negative log of the hydrogen ion concentration and plug in the value of 0.050, and we find that the pH is 1.3. As a follow-up question, is it an acid or a base? This would be an acid because the pH is less than 7. Here's one for you to try. A sample of household ammonia is found to have a hydrogen ion concentration of 1.26 times 10 to the negative 12. What is the pH of this ammonia solution? And is this ammonia solution considered to be an acid or a base? When you're ready, press pause, and once you think you have the answer, press play and check your work. Did you get that the pH is 11.9? If you did, good work. This was found by taking the hydrogen ion concentration and plugging it into the pH equation. So we took the negative log of 1.26 times 10 to the negative 12, and that gave us 11.9. The follow-up question asked if ammonia is considered an acid or a base. Since the pH is greater than 7, it would be a base. So the ammonia solution is a base. And that's a closer look at pH calculations. For more chemistry matters, go to our homepage where the entire series is available to you.